What is a perceptron? A perceptron is one of the simplest supervised machine learning algorithm. Okay. It's mainly used for the classification problems where the output belongs to one of two classes. Example for example for um, example for placed or not placed, approve or reject, yes or no, positive or negative, 1 or 0, just like a binary. Perceptron learns um straight line decision boundary that separate one class from another. A perceptron is loosely inspired by the human neuron. Both receive the information, process it, and produce a output. But biological neurons are far more complex. Okay, human neuron like dendrites, they are receive the information where the x1, x2 up to xn, they are called features. They are also receive the information. Okay, in the human, the synopsis 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 are control the importance of the information. In the artificial perception, weightage w1, w2, w up to n uh, work same. It's control the importance of the information. Okay, cell bodies cell bodies combine all the information in the human neurons, same as the weightage sum in our perceptron combine all the information. Okay, fearing mechanism fearing mechanism decide whether to active. It's same as the activation function. Okay, activation function. Another is a auction terminal. Send the result and forward it. That will be connected to the another neuron in the human body. But in that case, our output in the perceptron send the result to the forward. This give me the result. Okay. That is some differentiation. Uh, then the difference between the human perceptron is a living biological cell. No, sorry, human neurons are living biological cell, but the artificial perceptrons are mathematical algorithms. Okay, they're receiving the electrical and chemical signals. They are receiving the numerical values. Okay, learn through a complex biological changes. Learn updating the weightage and bias. Okay, their works are far complex in the human neuron compared to the perceptions. Hmm. And use the energy from the body, use the electrical power and the in the human neuron. Artificial perceptrons are use the electrical power and the computer hardware can be affected by the emotions, memory, hormones, and health. Human neurons. Artificial perceptions are has no emotion, considering or biological memories. Okay. Some example for a human interview also receive the information such as CGPA, aptitude, communication, confidence. However, the interviewer can be explained a context and judgment whether the perceptron only follow its learn a mathematical rules. Is one of the sentence the human neurons is far complex and the living cells, while the perceptron is a very simple mathematical model inspired by the basic idea of the receiving, processing, and sending the information. Okay. In this perceptron, x1, x2, up to xn, there are inputs, there are the features or measurable attributes of the data points that the perceptron used to make the decision. Okay, each input provide a signal that contributes to the final output. Example for OR gate inputs a binary x1, x2, 0, and 1. Input themselves have a no inherent influence unless multiple by the weights. And W1, W2, and Wn up to n, it is called the weights. What about the function of the weights? Weights determine how to strongly each input contribute to the perception. A larger weight means a corresponding input has higher impact. That's, we can say, the importance. Suppose in a student placement, we have a two feature. One there is CGPA, another is aptitude exam. So the aptitude exam weightage is higher than the CGPA weightage. Without cracking the aptitude, they are not go to any other technical round. So that's about. Then another is a one there is a bias. The bias is a constant value add to the weightage sum. Okay, constant value add to the weightage sum, shift to the decision boundary. It allowed the perceptron to classify the current event when all the input features are 0. Bias ensure the model is not forced to pass the decision boundary through the origin. Okay. It mentions the threshold value actually. In that case, our threshold value is 1, not maximum the 1. And this is our activation function. Okay. The activation function convert the numerical inputs to a binary output. Okay. Like a 0, 1. It introduces non-internally the decision making, although a decision boundary remains linear. Output is always 0 and 1, making the perceptron suitable for the binary classification. Okay. A simple example of the student placement. Suppose AI system predicts whether the student will be placed using two features. One is a CGPA, another is a aptitude score. Okay. The perceptron gives the importance to each feature using the weight. Okay. So let's store the result where W1 is the weightage. Okay. We can say it is the importance, store the importance, and in this CGPA is the feature. Here we store the value, and we sum with the weightage of the another feature and the aptitude plus B. This is the threshold value. Okay. Then the final value course the threshold output 1 is placed. Output, if the output is come 1, then it is placed. Output is 0, it is for not placed. Okay. Using a CGPA attitude, also we can consider some extra features like a communication, confidence, experience, context, and judgment. Okay. Perceptron is for the learn of mathematical rules a human can be used to border judgment. Here. Our another it is the weighted sum. Okay. So the perceptron first calculate the weightage combination of the input feature along with the bias term that helps to shift the decision boundary. Okay. Z equals to summation I equal to 1 to n wi xi plus b. The perceptrons belongs to the supervised learning, classification, linear classification, and binary classification. In the supervised learning, the model learn from the labeled data. Labeled data means they have an idea of the data set. Like example for the CGPA aptitude, a CGPA score 8.5, aptitude 82 score, and then say a higher chance to be placed. Another is a CGPA score 5.8, aptitude score 45, their chance to the target value is 0. Okay, the inputs columns are called the features, I can say, and the outputs column are called the targeted value. Okay, this is the formula of the perceptron. In the formula of the perception, where is the z equals to w1 x1 plus w2 x2 plus p, where the w1 is the weightage of the first feature and x1 is the input of the feature, w2 is the weightage of the second feature, and x2 is the belongs to the second feature. Okay, plus b means bias, a z the calculated score, total score. The weightage and the bias are learned automatically during the training. Okay, so the thing of the shine of the z decide the class. Okay, z is greater than 0, that means class 1 placed, less than 0 means class 0 not placed. This simple rule is called information. Okay, use a step functional, the perception used to the step functional to make the predictions. Okay, for the student placement, class 1 is placed. If the class is belongs to 0, it is not placed. Okay, we have some examples. Suppose the student A have a CGPA 8 as the first feature and the aptitude is 70 is the second feature. Weightage of the CGPA is the high 2 and the aptitude weight is 0.1. Okay, the 2 is multiplied by 8 and sum, then we sum it with the second feature and weight. The aptitude score is 70, this multiplied with 0.1, then the result is 5. Okay, and we minus by our bias value, this is called 18, then the result is 5. Okay, this is greater than to the 0, prediction placed. Okay, successfully placed. And another is student is B, where the CGPA is 5 and the aptitude is 50. So CGPA 5, our first features, it is multiplied by into 2. Okay, then we sum it with the second feature and their weight. The weight is 0.1 and the value is 50. Then we come with 5. Then we minus it by our bias value 18. Then the result is minus 3. It is less than 0. So not placed. Okay. This is our graphical representation of the straight line perceptron, where the uh, aptitude is the y-axis and the CGPA is the x-axis. Okay, so here we have a decision line. Okay, thus we separate the two classes. One is a class A, a class B. So class A is belongs to a placed student. Okay, and the class B is the not placed student. Okay. So using the two features to make the project easier to understand, visualize, advantage, easy to display on the two-dimensional graph, easy to understand the decision boundary, suitable for the beginners, easier for the model training, and easy to predict from them, and easier to explain during the presentation. Okay. Like some example of the CGPA and aptitude and the target value. The first feature is our CGPA and the second feature is the aptitude and the target. Okay.